Here's our lab presentation for design 330. It is week 6 and it's Friday the 26th. And I thought everybody's doing great work, and I've seen a bunch of your work, and most of you are pretty much done. But I thought I'd do a few extra things for you. And so I am recording this in case you want to do some extra cool stuff. And so here we go. The first thing I want to do is maybe add an O-ring to my assembly and a spring to my assembly. Okay, and so I need to model that thing. I could go up and get it out of the design thing. Okay, I find that they don't really follow all the exact design rules that I want to follow. So I'm going to do it from actually just making this thing. So there's an O-ring and there's a spring. So the O-ring I can just model as a torus, and the spring I can just model as a coil. And so I can either make it as a revolve or something like that. So let me go to the O-ring. And if I look at my primitives, let's see if they even have one for a torus. Look at that. There's a torus right there. Creates an axis and circle, revolves it as a 3D shape, pick your space. So you could do that. You could do that. How big do I make it? Well, this is my O-ring. It's got a 0.540 diameter, 0.674. So if I wanted to, I could draw a circle right there and revolve it. Okay, and my circle would be from here to here, which is that minus that 0.085. So my circle has a diameter of 0.085, and it goes right to the middle between those two. Okay, so what would that radius be? 0.674 minus 0.504, 0.17 plus half of this, right? So that's sort of this amount, 0.17, and 0.504 divided by 2. 0.504 divided by 2 plus 0.17, 0.422. So that's kind of what I'm going to do when I build this, right? So let me come back to here. I did it a slightly different way. Okay, so I kind of put it up on here and set it up this way. You see what I did there? Okay, so that's what I did. I went over 0.296. Actually, I don't know what I was doing with that last one there. It's 0.296 with a 0.087. And that sets the inside diameter at 0.504 and the outside diameter at 0.674, which is what I did my model to. So I just made that thing. Okay, I made it, and then I did a revolve. Okay, so that's how you make your O-ring, and I just called it something. And then when I put it in, see if I can find it. No, that's not what I wanted to do. I wanted to come back to here. I wanted to find the O-ring in here. Here it is. So if you look at the joint, I just did a cylindrical joint, and I put the center point of my torus on the center of this little cylindrical surface right there. And it just went right in. Okay, so that's how I put my O-ring in. I just fit it and I just added it in, right? Place the O-ring And the joint was, again, cylindrical. And I just picked my spots. The center of the torus went into the center point of those. Now let's see how to make the spring. The spring, I basically just made a coil. Okay. And I had to have something to make my coil out of. So I just drew something. I used 0.06 piano wire. I just made up something, 0.06. Okay, and I picked an axis, which in this case was my y-axis. Okay, so make a profile and run the axis. And then I use the pitch and height method. So pitch means how far between one coil and the same spot, the next coil up. So from here to the same spot up here. And I just put a number in. I put in 0.21. That seemed like a nice coil thing. It doesn't really matter because you're just taking up space. You're not making the spring. You're taking up space to show that a spring goes there. Okay? And so, but it is helpful to get something kind of like it. And then I calculated from here the distance between the roof, the top, and where it was going to sit. You guys were wondering why I drilled my hole all the way through. It's because I needed a little flat area down here for my spring to go on. See how it's sitting on just that little flat area, and the water will go right through. That's why I need some gap. If this is all closed up, it's going to be hard for it. Okay, but that's cool. So that was 0.312 and I measured it. So I made this 0.312. And you can see. So you pick a profile, which is a circle, and you spin it about an axis. In this case, it was my y-axis. I picked some sort of a pitch, and look, I made it 3 or 4 times the diameter of my spring so that it squeezes down, it won't be too bad. But I just wanted something. And then I just measured the height I need and I stuck it in there. And then I put it in. And again, I used this thing. I used the center point of this on the center point of this surface right here to place it. It came in right like that. So now I've got those. That's kind of cool. They're in my assembly, and I do a save. Of course, I have to save all these parts. And then look, when I go to my IDW, my drawing, and I come up here and I double click on it, the new things, well, they've been placed, the new things show up. Isn't that cool? They show up automatically if you refresh it by going into it. Okay, if it shows up in this view, they show up. And then I went to balloon and I was able to pick the 2 new parts. There was one and there was the other. And where I put them, this one maybe would look better. This one would maybe look better like pointing at that. Something like that. Hard to tell. There we go. That looks, well, it looked better as the dot. There we go. Just something that you can see. Okay, so that's how you update this now to add an O-ring and a spring. And we haven't really talked about those yet. So let's talk about them. Now that I've got this spring in here, and this is optional, remember. It's not required at this point. Right? But if you really want to, if you've got some time and you really want to update this, you could do that. So O-ring and spring are now added to my list of materials, my bill of materials. I would re-export that to get it into my spreadsheet, or just add the two lines. Let's take a look for a spring. So I've gone to the leaf spring thing. Remember, I said we might do this at some point. So let me make this a little bit bigger so you can see it. So I'm on the compression springs, and I'm going by hole diameter because that's what I've got. I've got a hole. I could do it by other things, but I have a hole to fit it in. And my hole is actually 0.44. And I'd go, yeah, if it got much less than 0.35, it would probably be maybe a little too wobbly in there. So let me see if I can find one between 0.35 hole and a 0.44 hole, something that would work. So I just picked a hole diameter that was similar to the size of this hole. I'm trying to pick the right stuff here. I'm having a hard time picking too much. But it's this inside diameter of your piston, inside diameter of the piston. Okay, so I picked that, and then I don't care about these in a free length. Well, that thing is 3.12, and I need to compress it at least a little bit. So I'll say it has to be at least 4 long. And if it gets too long, I can't squeeze it down. So I'll say a maximum of 10 inches. And that means that when this thing is sitting here all unexpanded, right now it's kind of compressed, right? The pressure is pushing on the top of here with my air pressure and pushing this down. So it's somewhat compressed, but you can see it can come back about another ½ inch, and it can go forward another inch or two without a problem. So I want to come back to here, and I want to pick something that seems reasonable. And look, if I need to make my tube longer, I can. But if it gets much more than like 10 inches long, it's going to be unwieldy. So I'm gonna make this between 4 and 10. And my rate, that means for every inch I squeeze it, how much harder do I have to push? So it's pounds per inch. So that if it's 5 inches long and it's pushing back with 50 pounds, when I get down to 4 inches long, it would be pushing with 60 pounds. Something like that, if it was 10 pounds per inch. So this rate, I don't want to go too much, or this, I won't have enough air pressure. And if I go too small, it won't push it back up strong enough to overcome the O-ring. Okay, and so then I came up here and it gave me 3 different springs out of all those 5,000, 16,000 springs. It picked 3 that met my criteria. So I could pick any one of these. So I might do one, and I would get in and I would calculate with these now. I do some calculations, but I kind of like 7 pounds per inch. Because remember, we talked that in one of our calculations, we wanted it to push back between 15 and 30 pounds, depending on how much air pressure I was using. So this 7 pounds per inch seems good. Now it's got a free length of 8. So that means if I squeeze it all the way down to 3 inches height, okay, if I squeeze it down, well, first of all, I can't. This has a solid height of 3.8. So that one wouldn't work. This one would, but I'm squeezing it down too far the way it is right now. Let's take a look at that. That's where I'm holding it, and here's where it's going to sit. So I've got my spring sitting here. Right now, this is 3.12. Okay, and I want to be able to compress it down at least another ½ inch, maybe even another inch. Let's see, how far do we want to be able to compress it down still? Look, there's a lot of travel left here for it to compress down. So I'd like it to compress down maybe another inch. And remember, we were saying that we had 2 or 2.5 inch of travel to get our volume that we were looking at. So all of these things, once I've got this, I'm still going to be tweaking on this some. I'm seeing that I probably want a longer tube. What might I need? Okay, let's say this is 7 inches. Let's look up here. Free length, 7 inches. Well, that means that there's no force at all. Let's say I make it 5 inches. How much force is that going to be? I've squeezed it down from 7. So this is my free length. That means it's just sitting there on your table, not doing anything. And this is my load 1. And I'm going to have a load 2. So this is at load 1 at 5 inches. And if this one is 7 inches, how much have I compressed it? I've compressed it 2 inches. So how much is my load? Well, my rate is, what is my rate? If I'm doing this one, it's 8 pounds per every inch. 8 pounds per every inch. 8 per inch. And I've gone 2 inches. So 8 times 2, my load is 16 pounds. And that's not too bad. I'm kind of pushing. I can make that go down. I can push that with my air pressure pushing down on here. I can push stronger than that. But let's say now that I squeeze it down. How far can this go down? Let's say I squeeze it down 1.5 inches. Okay. Because I can only go down to 3.2. Say I go down to 1.5 inches. That would be a 3.5. So I've gone down to by 1.5 inches. So my height here is now 3.5. And what's my load? It increased by 1.5 times 8. I've gone another 1.5 inches. So I've added another 1.5 times that. 8 times 1.5, 12. So I've added 12 more pounds onto it. I was at 16, so I add 12. Should be 28 pounds. So I'm pushing now. I have to push with 28 pounds to get it down to there. Okay, so there's a free length just sitting there, and I push it down and put my piston in, and it's sitting there, and that's good. And then I put some pressure on the back of it, and I squeeze it down 2 inches so that it's at 5 inches. And that's probably going to be like my starting place. Okay. And I know I have to push on the back of this with a force of 16 pounds to overcome the spring. Push it down. And if I want to push it down another 1.5 inches, I'm going to go down to a total of 3.5. But my 1.5 inches added 12 to the 16 gives me 28. So that's how we do springs. Now that it's all put together, we'll be looking at that. We're going to look at that more next week about how to actually pick that spring and add it in here. But if you want to be a little bit ahead and kind of look around and play and see what's going on, adding the O-ring and adding the spring to your assembly and your bill of materials is kind of cool. Now, if you've already done all of your work and presented it, that's okay. You don't need to redo your bill of materials or redo your rendering or redo your exploded view. But you might want to create this and add in a new page just to show that you did it or to be prepared for next week. Okay, so there we go. That is how to add a spring, add an O-ring, and actually sort of figure out what spring you might even want to use. I kind of like this one. I like that one probably the most. This one could be nice too. This one is pretty cool because it can get a little shorter. But I think I want the smaller rate if I can. All right. So there we go. That is our spring one for today. Spring and O-ring.